A router is a fundamental networking device that plays a crucial role in directing data packets across computer networks. Whether in homes, businesses, or the vast interconnected web of the Internet, routers enable the seamless flow of information. Understanding how routers work is essential for anyone seeking to grasp the intricacies of modern network architecture. Think of a router as the traffic cop of the Internet. It's a device that connects different networks together and directs data packets to their intended destinations. It's like the GPS of the Internet, ensuring that your data reaches the right place efficiently. Routers are the backbone of modern networking. They play a crucial role in forwarding data between networks, whether it's in your home, office, or across the globe. Without routers, we wouldn't be able to browse the web, send emails, or binge watch our favorite shows. They keep our digital lives running smoothly. 1. Basic components of a router. Inside the router's sleek exterior, you'll find a brain called the Central Processing Unit, CPU, and a memory bank. The CPU handles all the calculations and decision-making, while the memory stores important information like routing tables and configuration settings. If the router was a superhero, the CPU and memory would be its superpower. Interfaces and ports. Routers have multiple interfaces or ports, just like the USB ports on your computer. These ports allow you to connect different devices, such as computers, printers, or other routers. They are like the doorways through which data can enter or exit the router. Without these ports, your devices wouldn't be able to communicate with each other. Routing and switching modules. Routers have specialized modules responsible for routing and switching. The routing module decides the best path for data to travel from one network to another. It's like the router's very own Sherlock Holmes, always looking for the quickest and most efficient route. The switching module helps the router send data within a network, allowing devices to communicate with each other. 2. Routing protocols and algorithms. Distance vector routing. Distance vector routing is like sending a friend a series of directions based on the landmarks you pass along the way. The router shares information with its neighbors about the distance and direction to reach various networks. It then makes decisions based on this collective knowledge. Think of it as the old-school way of routing. Link state routing. Link state routing is like using a GPS that knows the exact map of the city. Each router in the network shares information about its connections and their status. With this detailed knowledge, the router can calculate the shortest path to each network using sophisticated algorithms. It's the modern, advanced way of routing. Hybrid routing. Hybrid routing takes the best of both worlds, like a fusion of two cuisines. It combines distance vector and link state routing protocols to achieve optimal performance. This approach is often used in complex networks that require both speed and efficiency. 3. Routing tables and forwarding packets. Routing tables are like the router's address book. They contain information about the available networks and the best paths to reach them. When a data packet arrives, the router consults its routing tables to determine where it should be sent. It's like the router's way of saying, I know where this needs to go. Packet forwarding process. When a router receives a data packet, it looks at the destination IP address and consults its routing tables to find the best path. It then forwards the packet to the appropriate interface, which acts as a gateway to the next network. It's like a digital postal worker, ensuring that your data reaches its intended recipient. Static versus dynamic routing. Static routing is like setting a fixed path for every data packet, regardless of the network conditions. It's simple and predictable, but not very flexible. Dynamic routing, on the other hand, adapts to changes in the network by constantly updating and sharing routing information. It's like having a real-time traffic update for your data, ensuring it always takes the fastest route. 4. Network address translation, NAT, and port forwarding. When it comes to networking, you've probably heard the term IP address thrown around a lot. Well, network address translation, NAT, is here to save the day when it comes to managing these addresses. NAT acts as a middleman between your local network and the Internet, allowing multiple devices to share a single public IP address. How NAT works. So, how does this middleman magic happen? Well, when a device on your local network wants to communicate with the Internet, NAT assigns it a unique private IP address. When the data packets travel back and forth, NAT keeps track of which private IP address they belong to and translates them to the public IP address. Port forwarding and its applications. Sometimes, certain devices or applications need to receive incoming connections from the internet. This is where port forwarding comes into play. Port forwarding allows you to direct specific incoming traffic to a particular device or service on your local network. Want to host a gaming server or access your home security cameras remotely? Port forwarding is your ticket to making it happen. 5. Security features and firewall functionality. Picture a bouncer at a club who decides who gets in and who gets kicked out. Well, access control lists, ACLs, are like the bouncers of your router. They determine which devices or traffic are allowed access to your network and which are denied. So, you can keep out unwanted guests and prevent potential security threats. Stateful firewalls and packet filtering. In the digital realm, a stateful firewall is your trusty bodyguard. It inspects not only the header but also the content of network packets to determine if they are safe to pass through. It tracks the state of connections, making sure that only legitimate traffic gets in while keeping the bad stuff out. Intrusion Detection and Prevention Systems, IDPS. Think of Intrusion Detection and Prevention Systems, IDPS, as the alarm system of your router. These clever systems monitor network traffic, looking for any signs of suspicious activity or potential attacks. They'll sound the alarm, figuratively speaking, if they detect anything fishy and take appropriate action to safeguard your network. 6. Wireless routing and connectivity. Wireless standards and protocols. Wireless technology has come a long way, allowing us to connect to the internet without being bound by cables. Different wireless standards and protocols, like 802.11 AC or Wi-Fi 6, define the rules of wireless communication. These standards determine factors such as speed, range, and device compatibility. Configuring wireless routers. Configuring your wireless router can be a breeze if you know what you're doing. From setting a unique network name, SSID, to securing it with a strong password, understanding the basics of configuring your router will ensure a smooth wireless experience for all your devices. Wireless security and encryption. When it comes to wireless connectivity, security should be a top priority. Encrypting your wireless network using protocols like WPA2 or WPA3 prevents unauthorized users from accessing your network and eavesdropping on your internet activity. A secure wireless network is like a fortress protecting your digital castle.